Hello dear friends, welcome back to my channel. I'm Gerard Beya and I'm here to study differentiation. So I'm revising my math and now I have to learn about differentiation. So we already did differentiation in high school. So what is it exactly? So as calculus is a study of the rate of change between variables, it is used in a huge number of real-world applications of mathematics. So differentiation is a rate of change. If we have, for example, dy by dx, usually that's how it is denoted. So it's just a rate of change of y in respect to x. That's what it means. It's how fast y is changing in respect to x, value of x. These are two variables, and y is expressed usually in terms of x. Let's say like this, and so that's why we say dy by dx. So when x is changing, y is changing, and what's the rate of change of y in terms of x or in respect of x. So that's what differentiation is. And like I just said, it is used in many real-world applications, and scientists use differentiation to analyze the growth of bacteria, for example, population change, the number of hours of daylight throughout the year, radioactive decay, and inflation rates in finance, to name a few. So these are the many applications of differentiation, and we're going just to refresh our mind before we get started with differentiation. So we'll need to know how to change the form of rational expressions like this. So if we have this, so 3 divided by x to the power of 3, we'll have to write it as well as this. So by bringing this up, the denominator up close to the numerator. So you have the numerator and you have the denominator. This is the denominator, this is a numerator. So we'll bring everything up here. So you see the power was positive and now it's negative up there. Alright, that was an example, and we have some other example for you. This is just half. The root square can be written as power half here. Some more complex or daunting example is this. By bringing the denominator up, we'll have 3 to the power of minus half. And yeah, that's correct. And there is no x here, sorry. So there is no x, but it's just this. So 4 times 3 to the power minus half. If there would be x, you'll have 4x to the power minus half. So that was just to check if you understand these things, and it's also a good check for me. Let's try something more complicated. Here we have x to the power of 5, and we are rooting it to the power of 3. So cubic root if you want. And so first of all, we can rewrite it down here. So it's 5 over 3. By bringing it up, it's going to be x to the power minus 5 over 3. So it's good to write it already in this form, in a rational form, so that you don't make mistakes by, just doing everything at once. And what else is that, when you are going to differentiate, you're going to minus 1 power. And so you will get this. So if you have half, you minus 1, you will get x to the power of minus half. So these are just simple arithmetics thing you need to know when you are doing differentiation. So we know that it's a rate of change, but there's something called the gradient, the gradient of the tangent. So what is a gradient and what is a gradient and what is a tangent? So if we have a curve here and there is a tangent touches the curve only at one place. So a tangent to a curve is a straight line that touches the curve only once. And let it be point P, and the tangent to a curve at any point P is a straight line that touches uh, the curve at point P. And usually it's perpendicular here, and that's what is a tangent. So we want to know, so how, if we take different points, you see that the angle is changing. The angle is changing. Um, so compared to the x-axis, so we see that the angle is changing. Here the angle is 0 at the minima. So the gradient of the tangent at any point is very informative, let's say, to know how the curve is changing. So if we have something like that, if we have something like this, different things. So that's why we have the tangent and the gradient of the curve. The tangent is just a straight line to a point, but the gradient is how it's varying. And how do we calculate this? Uh, so we know that the gradient is kind of the differentiation also. Differentiation is the method of obtaining the gradient in a very quick way, but it's the rate of change of y in terms of x, or in respect to x. So p is going to be y2 minus y1 divided by x2 minus x1. So if you have a point here, let it be 2, 2, and if you take xy here, so I can write it like x2 xy, and here I have x1 y1. So if you take these new coordinates around here, so to calculate the gradient, so you're going to have the gradient at point P, which is here. So you see that this is a formula for calculating the gradient. Just taking the difference, we can call it delta y divided by delta x. And this has to be very small. This delta x has to be very small. You cannot take a point that are, we cannot take points that are very far away. So here the gradient is like this, but here it's not like that. It's not the same angle. It's not the same angle. Although that here it looks like it's the same angle, but no, it's not the same angle. Delta x and delta y, especially delta x, I mean, because delta y is changing in respect to x, so it has to be small, has to be very small. Okay, this is very important. So we'll look at one example. So we have seen this p here, we have that, taking a point here, and then we have the gradient at p, which is, I'll just write gradient here, y2 minus 1 divided by x2 minus x1. That's the gradient. So now we're going to look at an example. So we have a curve here, and the curve is y is equal to x plus 2 to the power of 2. So what do we know here? This is a perfect square. So if we equate this to 0, so we'll get, of course, this is y, this is x. We'll get x plus 2 to the power of 2 is equal to 0. We have x is equal to minus 2. Okay, there is just a problem. That was minus minus here. So it's going to be plus, just to have the same thing on both sides. So I have 2 here, and that's where the curve touches. And we know that it's in this shape and not in that shape because remember when we were doing quadratics, if we expand this, we're going to have x squared plus 2 times 2 minus 2, sorry, x, and we have plus 4. So x ax squared is positive, so if it's positive it has this shape, u shape. So once again we have 2 here, and that's where it's going to pass. And x minus 2 to the square. So where is it going to cross the y-axis? That's when x is 0. So when x is 0, we have 4. So this is a point 4. So that's what we know about this curve. And of course, if it touches here, probably it's going to be symmetrical on this line. We know that minus b plus 2a. So minus b, we saw, well, we can recalculate this, x squared plus 2 times minus 2 times x. So this is minus 4. So it's going to be 4 on 2. It's going to be 2. Yeah. This is a line of symmetry of the curve. So very good. I'm just revising my math, by the way. I'm not a pro. I am prone to make mistakes. So what are we going to do here? We're going to calculate the gradient at the point. We are being asked to calculate the gradient at the point p is equal to 4, 4. And that's somewhere here. 4, 4 actually is here. Exactly here, because it's crossing here. Yeah, so this is the point. We can draw a tangent. If we draw a tangent, we can see that we want 2 points here that are not necessarily on the curve, but it should preferably be on the curve, not on the line, you know. So how to do this? So we have this. So we have y is equal to x minus 2 squared. We want to take 2 points that are very close, so we're going to take 3.5, and then we're going for x1, x2 we're going to take 4.5. So if we replace this here, so we have 3, 5 minus 2, we have 1.5 to the square. 1.5 to the square gives us 1.5 to the square gives us 2, 5. We'll have 2.25 or 2.5, sorry. And if we take this 4.5, we put it in the equation, we have 4.5 minus 2, which is to the square, which is 2.5 to the square. 2.5 to the square gives us, wait a second, is it 2.5? 4.5 minus 2, wait, 4.5 minus 2 to the square, 6, 5. So what we're going to do now, I'm going to erase what we don't need. Yes, 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 all this we don't need. We're going to calculate the gradient. The gradient once again is dy by dx, or delta y divided by delta x, or y2 minus y1 divided by x2 minus x1. So that's what we know, and we're going to calculate it by taking this value minus this value divided by this value and this. So 625 divided by 6.25 minus 2.25, sorry, divided by a full 5 minus 3.15. That's what we got here with those points close to the point P. So here we will have 4 and here we will have 1, so the gradient should be 4. And that's how it's written in the book as well. And I tried different things. I tried to take, like, instead of taking 3.5 and 4.5, I took like 3, and I took 5 for x1 3, x2 5. So if you're following, so we can try with this. We can try with this if you want. You will see that it's not going to be 4 necessarily, and you can make a mistake. So let's try, for example, y is equal to, once again, x minus 1. This is important because this is how to get the value. So when x is 3, this is 1, so you'll get y is equal to, sorry, move this. We got 2 to the square is 4, so we have 3, 4 here, yeah. And when x is 5, we'll get 4, which is 16, I guess. So we have 5, 16. So if we compute this, we have 16 minus 4 divided by 5 minus 3. So what do we get? We get 8 divided by 5 minus 3 is 2. We get 4. We still have 4, just like here. So the gradient is 4. Approximately, this is an estimation. So it works both ways, but you have to be careful how you're doing it. And remember to use a relationship to find y. If you decide to take a point here and here, you don't know exactly, because this is just a sketch. You have to compute it in this. So that's how you calculate the gradient. And we have been now introduced to gradient and differentiation. So we had this x minus 1. We had this curve, and so we managed to find the gradient and so on for points on this curve. So we say that at the tangent, so we got the gradient. And so now differentiation later on is going to be easier for us. We don't really have to do like this all the time. Yeah, we don't have to do this thing, delta y, delta x. We're going to use differentiation, so we can expand this. It's going to be minus 2x, yeah, plus 1, yeah. So I expand it because that's how you will be able to differentiate it. If we differentiate this, it's going to be 2, like this. This is differentiation. We didn't do it yet, but this is differentiation. So if I just want to put, for example, the value of 4 here, I will get 8 minus 2, I will get 6. So normally, uh, the gradient is 6 here. It's not 4. The gradient is 6 here because, once again, we just got it was an estimation. If we have to differentiate dy by dx, if you know what is differentiation, we have this. Once again, I will just check 2 times that times that, yeah, and this is plus 1, yeah, plus 1, plus 1. So 2x minus 2, if x is 4, because we took 4, 8 minus 2 gives us 6. So this is different from what we have calculated. So there is a difference between doing dy by dx and doing y2 minus y1 and so on divided by x2 minus x1. So there is a difference between the two. Okay, and so yeah, now what we can do, we can learn how to do differentiation uh, with limits. What I have seen so far is that, let's say we have y is equal to x to the power of 2, and we have coordinates like if we have a graph, have a curve, and we have here two coordinates, we have a and b, and a is going to be x, x2, and here is going to be let's say x plus h, and we're going to have x x plus h to the square. Why do we have this and why do we have that? Because we're just expressing everything in terms of x. Y is going to be this, so we put this inside of this to get this. So now we have these 2 points, and we're going to try to find the gradient for this. So, and you'll see that how things varies, and we will come to the differentiation procedure. So let's do this. We will erase everything, and we'll have point A and point B. I'll write it nicely. We have so x and x square, x plus h. We have x plus h to the square. Makes sense, right? Because we are on the curve y is equal to x squared. So what we want to do, we want the gradient, and the gradient is just delta y divided by delta x. So how to get delta? Okay, we did this. So we're going to erase this. We don't need this. We're going to calculate. We're going to calculate the gradient, and we are going to see the difference. So we have x plus minus x plus h. Yeah, I put the bracket because this will change sign, and I have x2 minus x. But we have to expand this. We have x squared plus 2hx plus h squared minus x minus h divided by x squared minus x. So what we see here, we can here this and this. What we can do, we can try to simplify qxh minus minus x. Wait, this is not correct. This is not this. Sorry, I just made a mistake. Let's start over again. Because here we have this and there we have y2 is this. I made a mistake here, sorry. And y1 is x squared. So if we want to do it, we just do x plus minus x2. It's not x, it's not this one. This is x minus x plus h. This is a gradient. So this will cancel. We'll only have h at the bottom. Yeah, now it's good. So let me now rewrite it. So we have x squared plus 2hx plus h squared minus x squared divided by h. This is the gradient, and we're going to simplify it, and you're going to come to a conclusion. So x squared will cancel with x squared, and we have h here. We can put it out. We have that was minus 2 2x 2xh. No, sorry, plus 2xh. So plus, that's the plus 2xh. Sorry for the bad writing, because by h. So h will cut in h, and then we have 2x plus h. So if h is small, tend to 0, so the gradient is 2x. So the gradient at any point on y is equal to x squared is going to be 2x if delta y is small, or delta x, sorry, is small. This is h in this case. So this is what we came to this conclusion. I will erase everything, and I will write the conclusion to which we came. We have y is equal to x squared, and the delta y by delta x, delta x is 2x. So this is differentiation. Differentiation is if we have y is equal to n x a, so it's going to be n a x a minus 1. So this is a little bit the formula for differentiation, dy by dx. So voila, that's how we came with this what we call the power rule. The power rule, because in differentiation later on you will see there is the quotient rule, we have the product rule, and we have I don't know, the exponential rule, and so on and so on, when you're differentiating. So this is the first, and this is about power. Yeah. All right. I hope you appreciated this. This is an introduction to differentiation, and I'll try to do some other things concerning differentiation. Thank you for watching. Leave your comments, and have a very nice day. Bye.